Hi, my name is Luis Alonso from Reuse Company, and I'm going to show you how the links coverage metric works with this video tutorial. The objective of this metric is to provide means for checking that the existence of needed links between requirements belonging to different specifications, one belonging of a certain abstraction level and the other one level above or below. This analysis is done by means of transforming requirements from both specifications into formal representations, and then using mathematical graph algorithms to compare those representations to get a similarity quantitative value. This value will be the similarity ratio between the requirement from the source and the one belonging to the target specification. It is important to remark the direction of the comparison. These algorithms do not compute the same value from source to target than the other way around. This process is run for each requirement from the source against every requirement in the target. Let's say if we have 1,000 requirements in the source and 200 requirements in the target, there will be 2 million operations to be done. A parameter of this metric configuration is the threshold to filter the computed similarity for the requirement pair. If it is lower to it, the metric assumes that there is not enough similarity to have a link, but it is equal or greater, a link must be found in between both requirements. Thus, checking the existence of this link between the source and the target requirement is the next step of the evaluation process. For example, provided that we have these two link sets to hold links between the selected source and target specifications. If the link is found, like in example number 2, the metric computes one valid link. Otherwise, like in examples 1 and 3, a missing link will be annotated and added to the results. The final score is computed using the ratio between the missing links and all the candidate links found. To be able to assess this metric, it is necessary that the requirements repository is able to hold links. The only ones RQS supports with this capability are those from IBM and Visual requirements from Visual Solutions. After the theory, it's time to show the metric. First, we have two different specifications in a DOS database. ISO 17361, which is the specification elaborated by the ISO to define the functionality of lane departure warning systems, and the LDWS and HTSA, which is another specification created by the American agency, the FMCSA, about the same type of systems, LDWS. Also, we have a link whose name is related that holds links between requirements from both specs in both directions. Then we are connected with RQA to the project containing both specs, ISO and LDWS. We want to check that every requirement from one specification which is similar to the other specification has a link in the related link module. So we go to the project configuration tab, then select the source module and go to the Completeness button and create a new links coverage metric by using the suitable contextual menu option. We rename it into ISO versus NHTSA 50%, okay, and then we go for the configure missing links metric button. The source module is automatically set to the current module ISO, and then we select the target module from the current connection, LDWS and HTSA. Then we check the pattern groups to create the formal representations if they are suitable or not. In this case, it is fine. The creation and edition of pattern groups and patterns is out of scope for this metric, please revise other video tutorials of Knowledge Manager for this purpose. Then we have to select the threshold to filter the similarity values. In this case, we leave it as it is, 50%, as they are specs from different organizations and different backgrounds, so the similarity will be not very high. The last parameter to set up is the link module to check the existence of the calculated links. In our case, we select the related link modules and click on Accept. Then we click on Accept again, and now we have the metric with a quality function. Definition of quality function is not in the scope of this metric video. Then, switching back to Quality Control tab and Completeness button, we can access the new metric. Just select the metric, right-click on the mouse and select Recalculate Quality. After some moments, the result will be displayed. The result is 1.00, which means 100% of incompleteness, what means that every link computed was not found in our link module. Just clicking over the metric with the right button of the mouse and selecting View Quality will show further details of the metric assessment. The first pie chart focuses on the ratio between found and not found links. In our case, 9 missing links were found, while 0 already existing links were found. Clicking in the red pie chart area will move us to the Requirements tab, where the involved requirements will be detailed. Going back to the first tab, the second and the third pie chart focus on the requirements from source and target specs which have been assessed to have found or not found links. In our case, in the second chart, there are 5 requirements with links that are 20% and 20 requirements that are 80% that are not calculated to have links. The same idea works for the third chart. In the second tab, links coverage, the pair of requirements whose similarity is over the threshold are shown, sorted by similarity. Requirements from source specification are on the left column, and the ones from the target are on the right. They are followed by the link column, where the already existing links will be displayed. In our case, it is empty. The last column is the similarity value. Opening the contextual menu over any pair will allow different operations. Show similar pairs, which displays the requirement statements back to back. Then we have edit source requirement or edit target requirement. Then we have open source requirement endorse in this case, or the target requirement endorse, or create link. In our case, the latter will be the most valuable one because the link is what we are missing, so let's create it. We select Relatives link module and we click on Create. And our link will be created. The next tab, Requirements, shows the computed pairs of similar requirements from a different perspective. From source, its requirement from the source is similar to some requirements in the target, the other way round, from target to source. The contextual menu options are essentially the same done in the previous tab. Show pair, edit requirement, opening them indoors, or create the missing link. In any case, on the top of the tab, there is a slider which moves the threshold, so you can see if it will be better to modify the threshold to shrink or widen the result set. Finally, the last tab, filtering, shows how the requirement specs are filtered. In this metric, the only filter to be taken into account is the one separating those rows which really are requirements from those which are not set up in the source module and the target module configuration. Select the source or the target and then navigate in the requirement matching the filters or in the requirements not matching the filters. Now, as we have created a new link, the assessment is out of date. We recalculate the metric again to see the improvements done. Now, the incompleteness is 89%. And if we see the details, 8 pairs are missing, but 1 has been found. This one found provokes that in the source and the target specs there is one requirement with all its compute links created in this module, so it is shown in green in the pie charts. This is the links completeness metric. Thanks for watching.